Yes. Today we will study what motion on an inclined plane. Means rotational motion on an inclined plane. So look here. Rotational motion. Rotational motion on an inclined that study about rotational motion on an inclined plane. Right. So look here, this is very important concept. This is very important concept for you. What is inclined plane? This is our inclined plane. Take an object on this plane. This is an object kept on this plane. If the surface has some friction coefficient, then body will start rolling on the surface. So we consider pure rolling of an object. We consider pure rolling of an object on inclined plane. We consider inclined plane के जो है हम लोग प्योर रोलिंग कंसीडर कर रहे हैं. क्या होगा? We will consider pure rolling of object on inclined plane. So look here, what is the FBB? If this angle is theta, then from the center mg force will act on it. Mg sin theta force will act on it. Okay, the frictional force will act along the surface. This is F. And this is rolling frictional force. The rolling coefficient of friction is generally lesser than that of the kinetic coefficient of friction and static coefficient of friction. So still this force will be equal to mu mg cos theta or F. You consider F. Frictional force acting on the surface is F. So here mg weight of the body will act, and the normal force acting on the body will be this. Say moment of inertia of the object is I and its radius is r. Okay. So consider its translational motion. Consider translational motion of object. Objects. Its linear acceleration भी, इसका linear acceleration क्या हो जाएगा? Its linear acceleration भी, its linear acceleration, इसका linear acceleration क्या हो जाएगा? A must be equals to or we can write down here mg sin theta. mg sin theta minus F. mg sin theta downward directions and F friction force in upward direction. So mg sin theta minus F will be equals to mass time of its acceleration. And this is our equation 1. Now net torque of the body about its center of mass क्या होगा? नेट टॉर्क यदि हम सेंटर ऑफ मास के अबाउट निकालेंगे तो नॉर्मल फोर्स का टॉर्क कितना हो जाएगा? 0. ये mg sin थीटा है या mg है या इसके अलोंग एक कंपोनेंट हम लिखते आए हैं mg cos थीटा है ये सारे कंपोनेंट्स या mg फोर्स का कंपोनेंट सेंटर के अबाउट क्या होगा, जीरो। सो देयर इज ओनली फोर्स F, सिंगल फोर्स फ्रिक्शन फोर्स है, जिसका एक मोमेंट होगा किसके अबाउट, यहाँ इसके अबाउट होगा, सेंटर के अबाउट होगा, और इसके कारण इसमें एंगुलर एक्सेलरेशन भी होगा। समझो ना, इक्वेशन ऑफ मोशन जो हम लोग लिखे हैं, तो नेट टॉर्क इज इक्वल टू क्या होता है, आई अल्फा। नेट टॉर्क इज इक्वल टू क्या हो जाता है, आई अल्फा। क्लियर है ये स्टोरी, हाँ। सो net torque on a body, net torque acting on a body about its center of mass क्या हो जाएगा, about its center of mass, net torque tau must be equals to what, F dot what, R, F dot R, and due to this torque, if angular acceleration of the body is alpha, if angular acceleration of the body is alpha, due to this torque, if angular acceleration of the body is alpha, angular acceleration of body is alpha, then F dot R must be equals to I alpha. Again, what is the relation between linear acceleration and angular acceleration? Alpha is equals to A upon R. What are you saying? Yes, alpha will be equals to A upon R. So we may write down here F dot R is equals to I into A upon R. Since A is equals to alpha R, or alpha is equals to A upon R. This is our equation 2. Now from equation 1 and 2, what we can say, if we put value of F in equation 1 and we will compare it, you can have the value of acceleration on the inclined surface. Are you understanding? So here F will be equals to what? Right now F will be equals to I A upon what? R square. Now from equation 1, now from equation 1 क्या हो जाएगा हम लोगों के पास, mg sin थीटा, mg sin थीटा माइनस ia upon r square must be equals to what, mass times of acceleration. This implies that mg sin theta will be equals to what, m plus I upon r square into, clear? So A can be written as, therefore A, acceleration of the body, can be written as mg sin theta upon m plus I upon r square. Still we can see here, see here what is the acceleration in one line. We have considered previous time. Acceleration will be equals to npf by tm, and here we will consider the rotational effect of object. So we have to take I upon r square. Mass of the rotating object is taken as I upon r square. So this is complete analysis, but on tricky way we understand this from previous classes. Okay, so our acceleration will be npf, net pulling force is what, mg sin theta, and the mass is m, and the effective mass of this rotating object will be what, I upon r square. Is it clear? Write it down quickly. उसको लिखिए आप लोग। लिखिए लिखिए आप लोग, कॉपी कर लिए, टाइम वेस्ट नहीं कीजिए। So the final result is that acceleration of the body is I upon mg sin theta by m plus I upon r square. Sometimes it is also written as I is equals to mk square. We write down I is equals to mk square. Here the m is the mass of body and k is radius of dilation. Are you understanding? So here this can be written as further mg sin theta upon what? M plus this word mk square upon what? R square. Mk square upon R square. M will cancel out and this will be g sin theta upon 1 plus k square upon what? R square. Again you can look here for same mass and the same radius. For same mass and same radius, MOI of the body, same mass and same radius, MOI of the body will be directly proportional to their moment of inertia I. That is, यदि आपके पास एक रिंग है जिसका मास क्या है m है और रेडियस r है, और एक डिस्क है जिसका मास m है और रेडियस r है, दोनों का मोमेंट ऑफ इनर्शिया सेम नहीं होगा। क्यों? दोनों का मोमेंट ऑफ इनर्शिया सेम नहीं होगा। रिंग का होगा ज्यादा, मींस रिंग का क्या होता है mr स्क्वायर और डिस्क का होता है हाफ mr स्क्वायर। डिस्क का मोमेंट ऑफ इनर्शिया कम हो गया मतलब उसका एक्सेलरेशन क्या होगा? ज्यादा होगा, डिस्क का ज्यादा होगा। समझ रहे हैं? अगेन फॉर द सेम shape if the smaller disk is kept and the larger disk is kept, in two cases it will be independent of their mass. If the object is same means disk is again replaced with disk may have any mass and any radius, then their acceleration will be same because mass get cancelled and their ratio of k square upon r square for a given shape is constant about their central axis. Are you understanding? So about their central axis, value of k square upon r square will be constant. So look there, copy it.